Okay, so your test, guys, over P2, P3, P6 is on Tuesday when you come back from the long weekend, all right? I'm going to get through most of this review today. I will finish it up tomorrow, and then I'll post this so you guys will have it to rewatch over the weekend, all right? You have 12 questions. 12 questions. 2 of them are going to be from P2, P3. So one simplifying and one expanding. I'll show you that in a second. And then 10 factoring. So it is super duper important that you guys go through this list for every single factoring problem that you encounter. The first thing you need to ask yourself is there a GCF? Once you take the GCF out, then determine what's left over. If it's 2 terms, is it the difference of perfect squares? If there's 3 terms, is it a perfect square trinomial? Or can I multiply A times C and figure out what my 2 binomials would be? If it's 4 terms, is it grouping? That sort of a thing. Now, these first 4, okay, everybody listen, these first 4, I wanted to do as an example, but they will not be on your test. I just wanted to show you what could happen sometimes so you guys don't just go, oh, I already know what the answer is. I don't even have to check my work and I just want you to focus on not making these mistakes. All right, the first thing you ask yourself, is my polynomial in standard form? Yes, okay. Do I have a GCF? Yes, 7v, right? So I'm going to take 7v out of each term. 7v. Say it again, sweetie.
You simplify, right?
Yep. So we're going to take out 7v, and I'm going to be left with 5v squared plus 4v plus 9, correct? Now, at this point in the problem, I have a trinomial. So I would say, okay, well, A times C. Factors of 45 that multiply to give me 45, but add to give me 4. And yesterday, people were working on this. They said, oh, I know, positive 9, negative 5. And then they went ahead and they, put their 2 binomials out and they moved on to the next one. I said, guys, check that. What do you mean check it? I know, 9 and 5. Look at your signs, guys. I want a positive 45 when I multiply. If I multiply 9 and negative 5, does that give me a positive 45?
It'll give you a negative.
Gives me a negative 1. So just because 2 numbers seem to work, make sure you go back and check your signs. This is as simplified as you can get this question. I want you guys to see that. All right, again, on your test, all of them will factor out perfectly. I did all 8 versions. I worked every single one of them out. I fixed any boo-boos there were. Everything factors pretty. Yes, sir?
If it was like negative 9, you would multiply it with the 5 times the negative 9, and it would just be like negative 45, and you're fine.
Then it would work, yes.
Okay.
Let's go to 3, and then I'll go over to 2 and 4. All right, what's wrong with 3, the way that it's written? It's not in standard form, all right? We don't like it when it's not in standard form. So let's rewrite it. So I have 81 n to the 5th. And then I have plus 36 n to the 4th plus 9 n to the 3rd. Everybody with me? All right, GCF. 9 n to the 3rd. Perfect. So I'm going to take out 9n cubed. Remember, show me as much work as possible. Show me all of your thinking. So 81 divided by 9 gives me 9n squared. 36 divided by 9 is 4n. And then 9n cubed divided by 9n cubed gives me 1. Now I got here on this problem, and some people said to me, wait, it's a perfect square trinomial. Well, 9n squared is a perfect square. 1 is a perfect square. I do have a plus at the end. So maybe it could be, but if you guys were to work it out and put 3n plus 1, 3n plus 1, and then FOIL it out, you will not get 4n in the middle. If you went the route of A times C, 9 times 1 is 9. Factors of 9 that multiply to give me 9 but add to give me 4?
There's none.
There isn't any. So this is the most you can do. So don't just assume because it looks like it might be a perfect square trinomial or something like that. If you think it is and you actually put the 2 binomials down, FOIL it out to see if it works. If you were to do this, 3n plus 1, 3n plus 1, and then just move on to the next one, you're not going to get your answer correct because that's not a perfect square trinomial. So just make sure you guys pay attention to that. All right, let's scoot over to 2 and 4. All right, let's do 2. Are we in standard form? Yes or no? Yes. Okay, we're good. So first question you ask, is there a GCF? 3n, perfect. Remember, anything you factor out, go ahead and write it underneath so I can see your brain working. I see what you're doing. 3n to the 4th divided by 3n is 3n cubed. 6 divided by 3 is 2, and then I'm left with n. And then 18n divided by 3n gives me 6. Am I left here with a quadratic trinomial that I can factor?
I have no clue what you just said.
Am I left with a quadratic trinomial? Quadratic means the highest exponent is 2. No. So I can't break this down into n times n and all that because that would give me n squared, not n cubed. This is the furthest that you can break this down. Got that?
I feel like this. Is this fine?
Yeah. Yeah, that's fine.
Wouldn't it be n cubed instead of 3n?
Oh, this part here? Is that what you were saying, Josh? I'm sorry. Thank you. Yeah, like that. But can I break that down?
No.
No. All right, here. GCF.
9x squared.
Can I take a 9 out of all of them? Okay, so 9x squared. Divide by 9x squared. 9x squared. 9x squared. 9 divided by 9 is 1. X to the 4th divided by x squared is x squared. 54 divided by 9 is
-6x.
good, negative 6x. And then negative 36 divided by 9 is minus 4. All right, so I have now a trinomial. That is a quadratic, so I can say, okay, a times c. Here's my 1, so 1 times negative 4. Are there factors of negative 4 that'll multiply to give me negative 4 but add to give me negative 6? No, so this is it. So I just wanted to bring this to your attention. I promise you on the test they'll all factor out. I didn't put any prime or anything like that. I want you guys to be able to work them all out. They're not all going to be super easy and super straightforward, but I want you guys to work them all out and that they'll be able to. Okay, so what I need you to focus on is 5 through 22. You can go ahead and cross off 23, 24, 25, and 26. I put those on for extra help, extra practice, that sort of a thing, but I don't want to confuse anyone. So if you want to go over those, as soon as I'm done recording, I will go over them with you, no problem. Yes, sir.
I submit.
All right.
We already did that.
Okay, here we go. We're going to start with number 5. We're going to work down the left-hand column and then back up the right side. I will not finish this whole thing today. That's okay. I'll finish it tomorrow. But you guys will have all of this done before the weekend so you can review. So the first question we ask ourselves every single time we factor is what? GCF, okay? Number 5, is there a GCF? Can I take a letter and or number out of v squared plus 2v minus 15?
No.
No, so I say, okay, it's 3 terms. I'm going to multiply a times c. 1 times negative 15. What are the factors of negative 15 that multiply to give me a negative 15, but add to give me a 2?
-5 and 3.
Okay, so v plus 5, v minus 3. So check your signs here, guys. A positive 5 times the negative 3 is negative 15, yes? Positive 5 minus 3 gives me positive 2. So we're good. Take the extra second to just check. If you get the factors right but the signs wrong, you're missing a majority of this concept, so you're not going to get lots of credit. Number 7, GCF. No, okay? Is this a trinomial? Yes. So I'm going to say a times c.
6.
Okay. Factors of 6 that multiply to give me 6, but add to give me a negative 5.
-2 and -3.
Okay, I love this question. I need a negative 5 when I add them together, but a positive 6 when I multiply. Okay? A lot of people want to say 6 and negative 1, and then we have negative 2 and negative 3, right? Well, or I'm sorry, we'll do negative positive. I agree, guys, that negative 6 plus 1 gives me negative 5. But what is negative 6 times 1? Negative 6. What do I need it to be? A positive 6. So that's why we have to use negative 2, negative 3. I need negative 2, negative 3 to give me a negative 5 when I add, but a positive 6 when I multiply. Now, some of you are like, oh, I put negative 6 and 1. Well, take 2 seconds to just check. Take 2 seconds to FOIL it back out and see if you get your original equation, original polynomial. So if you had, Riley, you had minus 6 plus 1?
I put negative 6 and negative 1. I didn't even.
Oh, okay.
Yeah.
Well, again, that's okay though. That's okay. If you had negative 6, negative 1, and then you FOILed it out, p squared minus p minus 6p plus 6. Okay, I see where you got your plus 6, but what's going to be here in the middle? A negative 7p. And we want it to be 5. So just check. It takes 2 seconds.
I hope positive.
Okay, positive 6, negative 1. Watch what happens. Plus 6 and p minus 1. P times p is p squared. Then you have minus p. 6 times p is plus 6p. 6 times negative 1 is negative 6. So right here is your positive 5p. But Jonah, then this gives you a negative 6 at the end, and you want it to be positive.
I put them both negative because.
All right, let's look here then at number 9. First question we ask ourselves, is there a GCF? Is there? Yes, what can I take out? 3. So if I take out that 3, I have 5m squared plus 7m plus 2, correct? All right, I'm left with a trinomial. Can I factor this trinomial? Well, let's multiply a times c. 5 times 2 is what? 10. What are the factors of 10 that multiply to give me 10 but add to give me 7?
That's 5.
Okay, so I have m plus 5 and m plus 2. All right, I agree with that. My 3 is still out in front because I factored it out. But, guys, I have one more step because my a term in 5m squared is not 1. So what do I have to do with that a term? I have to divide both factors by my a term. So divide by 5, divide by 5. So my answer would be 3 parenthesis, what's 5 divided by 5? 1. So I have m plus 1 times, what happens with my second parenthesis? That 5 becomes my coefficient. So 5m plus 2. And there is your answer. All right, guys, look at this next one. Look at number 11. Is there a GCF in 11? No. So I look and I say, okay, is this a trinomial? It is. A times c, I'll do it down here on the bottom so I don't get confused. 2 times 12 is 24. What are the factors of 24 that'll multiply to give me 24 but add to give me 11? Yep, n plus 8 and n plus 3. Now, is my a term, Riley, is this number in front of n squared 1? No. So that means, ooh, I have to do that one extra step. And then I say, okay, well, 8 divided by 2 is 4. So my answer would be n plus 4. And then 3 over 2 doesn't work out nice and pretty, nice and neat. So this just becomes my coefficient. I have 2n plus 3. And you can always check, guys. Take 2 seconds to just FOIL that back out and see if you get your original expression. If I look at number 13, GCF on 13. No, so I'm just going to say, okay, is this a trinomial, quadratic? Yes. So a times c, 4 times negative 15 is negative 60. What are my factors of negative 60 that multiply to give me negative 60 but add to give me 4?
Plus 10 and negative 6.
All right. 10 and what?
Negative 6.
Okay, 10 and 6. P plus 10, p minus 6. If you guys don't see that right away, write the factors down. 1 and 60, then divide 60 by 2 and put 30, then divide 60 by 3 and put 20. Just work it through using your division skills. But I notice here, guys, look, a is not 1, it's a 4. So I have to put the 4 underneath both of these. Now, at this point, you should see that 10 over 4 and 6 over 4 both do what?
Simplify.
They simplify. You have to simplify. If you leave this as 4p plus 10 and 4p minus 6, you're getting points off. Because if you just go like this, 4p plus 10 and 4p minus 6, right? We just move the 4's over. When I go to FOIL this out, what's 4 times 4? 16. What do I want it to be? 4. So you guys, you missed piece that you had to simplify. So simplify those fractions. You guys, everybody in here can do that. What can I divide both 10 and 4 by? Okay, so this becomes 5 over 2. What can I divide both 6 and 4 by? 2. It becomes 3 over 2, right? So now my answer, when I write it correctly and in proper form, 2p plus 5, good. 2p plus 5 and 2p minus 3, perfect. Did you get that one right? Good job. You're going to get this. All right, let's look at 15. But if you go through the list, say the same thing every single time. Is there a GCF? No. Is this a trinomial that I can multiply a times c? Yes. So 4 times 1. Guys, I want a positive 4 when I multiply, but I want a negative when I add. In order for me to get a positive when I multiply, I have to have 2 positives or 2 negatives, right? Yes or no? Okay. So I want a 4 when I multiply, but a 5 when I add. What are my factors? Minus 4 and? I need 2 negatives. 2 negatives. Now I look and I say, here's my a term. My a term is 4. So what do I do with that a term? I divide both factors by that a term. Perfect. So 4 divided by 4 just leaves me with 1. So it's b minus 1. And then 1 does not divide pretty by 4. So I, God bless you, have 4, God bless you, b minus 1. That's a b, not a 6. With a little God bless yous mixed in there. All right, then we get to 17. Last period I said, okay guys, we get to 17. What do we do? This kid said, I just cry. No, he told me he just cries. All right, let's go back to our list. First thing we ask ourselves, is there a? Is there? No. Okay, so now I say, how many terms are there? I can't go a times c and multiply, right? Because I don't have enough terms. So then I say, all right, this has to be something special. What do you notice about the first term and the second term? They're both what? Perfect squares, good. And what do you notice about the sign in the middle? It's a difference. It's a minus. So I have the difference of perfect squares. What is the square root of 9n squared? 3n and 3n, good. What is the square root of 25? 5 and 5. So I have 2 parentheses that have the same terms in them, 3n in the front, 5 in the back. But my signs are different or the same? Different. Does it matter where I put the plus, where I put the minus? No. Thank you, sir.
Wait, they're different.
Okay, 19. 2 terms. What could it possibly be? Difference of what? Difference of 2 squares. Difference of perfect squares. What times what gives me x squared? I have an x and an x. What times what gives me 9? 3 and 3, good. So I have x and 3 in both of my parentheses. What are my signs? Plus and minus. They're different. It can be minus and plus. Does not matter. Okay, 21. What's the first thing you ask yourself? Is there a GCF? Is there one? Is there a GCF of all 4? No. Okay, so is this 3 terms where I just say a times c? No. 4 terms. What do we do when there's 4? You group. Good.
Are we going to have 4 terms?
Yep. So we're going to group the first 2 and the second 2. Anything I go over, fair game. So now look at just that first parenthesis. What can I take out of 42a cubed and negative 24a squared? I can take out a 6a squared. So if I divide by 6a squared, I'm left with 7a minus 4. Agreed? Okay, so what should my second parenthesis look like?
Divide by -1?
I should. I have to take out a -1 because I want my second parenthesis to be the same as the first. We're creating or we're finding a new GCF. So I'm going to take out a -1. I'm going to divide out a -1. And I'm left with 7a minus 4. Do you guys now notice that these 2 parentheses are the same? That's my new GCF. So I take that out. I rewrite it 1 time out in front, 7a minus 4. And now it's gone. And what happens to my poor little leftovers? I combine them. They get their own house. They get to hang out together. And there we have our factored answer. Now, guys, I want to bring something to your attention. I'll bring it to your attention after we do this next problem. We're going to scoot over to the right and go up the even side. So we're going to start with the hardest ones and then go back up and finish with the easier ones. If I have a problem that looks like this, don't get overwhelmed by it. The first thing you ask yourself, is there a letter and or number that goes into all 4 of these? No.
No.
3 doesn't go into 56.
But you group them.
So I'm going to group because I have 4 terms. If there is something that goes into it, take it out and then ask yourself the questions again. So 32 and 12, what can I take out of 32 and 12?
4x squared.
I can take out 4 and an x squared, good. So if I divide this by 4x squared and 4x squared, 32 divided by 4 is 8x minus 12 divided by 4 is 3, and my x squareds cancel, correct? All right, what about negative 56 plus 21?
-7.
Negative 7. We lead with a 7, factor out the negative, good. So I'm left with 8x minus 3. What do you notice about the 2 parentheses that are now in your problem? They're the same. That's our new GCF. So we're going to bring it out in front. 8x minus 3. And then what happens with our leftovers? You put them together. 4x squared minus 7. That is your answer to that problem. Everybody write that down. All right, quick little side note, guys. All right, this is, just pretend that this was the answer to that problem. Thank you. Pretend that this was the answer to that problem. You have to make sure that everything is completely factored. Would this be completely factored?
No.
No.
Why not?
The -9 and the 4x are perfect.
4x squared and negative 9 are they're both perfect squares. So you guys would have to say 8x minus 3 and then break that down into 2x plus 3, 2x minus 3. You may see something like that.
We don't have to do
Just
that.
saying.
Do we have to do that
On
now,
this
though?
test?
Yes, on this test. You have to fully factor. You can't do that here because that's not a perfect square. But just saying this, hold on, just saying this was your final, this was the answer you came out with, you have to go, okay, wait, let me just make sure, is everything completely simplified? If you can go one more step, because it's different to perfect squares, you have to be able to recognize that. All right, so scooting up, they're going to get a little easier because we're going back up. What do you notice about 20? Right away, you guys should see, oh, it's the difference of perfect squares. There's no GCF. There's 2 terms, so I can break this up into what and what? 4n and 4n, good. 1 and 1. So what are my 2 parentheses? 4n minus 1 and 4n plus 1, good.
It doesn't matter if plus.
Nope, doesn't matter which plus is the plus or the minus, which is first.
Is this fine if you just leave it?
All right, 25x squared minus 16, GCF? Is there a GCF? No. But always ask yourself, even though you just see 2 terms, always say, hey, wait, is there a GCF? There is not, so I have 5x and 5x. 4 and 4, good. So my 2 parentheses would be 5x minus 4, 5x plus 4. Or vice versa, you can have plus then minus, doesn't matter. Good. All right, you get to 16. And you guys are saying, oh my gosh, it's just so much. If you go down the list and say GCF first, is it a trinomial? If you get in that habit, it's good. But if for some reason you get to something like this and you say, okay, A times C, do you really want to multiply 12 times 18 and then find out the factors of that that'll give you 33? No. What do you notice that this has? It has a GCF. What can I take out of all of these? The 3. Simplify your process. Make everything as easy as possible on yourself. If I take out that 3, I'm left with 4m squared. What's 33 divided by 3? Good. 11m plus 6. So now I have a trinomial where a is not 1. That's okay. I'm going to multiply. 4 times 6 is 24. What are the factors of 24? We already had this. That multiply to give us 24, but add to give us 11. 8 and 3. So I still have the 3 that I factored out. I'm going to write it out in front. Then I have m plus 8 and m plus 3, correct? Okay. Now, is that my final answer? No, because this a term, remember guys, was not 1. It's a 4. So I need to divide out 4 from both sides of this. When I do that, my final answer would be 3 times m plus 2, right? And what's my second parenthesis? 4m plus 3. Good. This 4 becomes the coefficient. All right, GCF. No. Okay, so A times C. 4 times negative 15 is negative 60. What are the factors of negative 60 that multiply to give me negative 60, but add to give me a negative 4?
Negative 10 plus 6.
And minus 10 and plus 6. Again, if you don't see that right off the bat, guys, go right here, 60. 1, 60. 2, 30. 3, 20. 4, 15. 5, 12. 6, 10. All right, then actually look at it. Say, okay, what'll work? But is this problem done? No. What do I have to do? Good. Divide both factors by 4. And what do you notice about when I do this? I can simplify. I can say 9 minus 5 over 2. Not 9. I don't know why I said that. N. And then n plus 3 over 2. And then when I write my parentheses nice and pretty, what are they? 2n minus 5. Good. And 2n plus 3. Good, John. 2n plus 3. Good, good, good. GCF?
No.
No. Trinomial? Yes. Can I say A times C? Negative 10. I need the factors of negative 10 that are going to multiply to give me negative 10, but add to give me 3. Negative 2, positive 5. Agree. One more step. I got to divide both factors by that A term, which is 2. So I'm left here with x minus 1 times 2x plus 5. Great. Great, great, great. Scootin'? GCF? Like, I just answered that question. 3 times 8 is 24. We've had a lot of 24s, but I haven't had to where I've had to multiply to get negative 14. Positive 24, but add to get negative 14.
Negative 12 minus 2.
Ooh, good. Minus 12 and n minus 2. Again, if you don't see that, guys, over here on the side, factors of 24, 1 and 24, 2 and 12, 3 and 8, 6 and 4. What could somehow give you 14, and that would be our 2 and 12. So now I'm going to take my A term, divide by 3, and my parentheses become
4n minus 2.
n minus 4,
Oh.
right? And then 3n minus 2. I know what you meant. You said it backwards. I got you. No worries, no worries. 8.
Yes.
Guess what? GCF. Good. You're getting in the habit of asking the questions. Is there a GCF? Yes.
No.
This is the same question, Sarah, you just asked me about a minute ago. This is the same thing. If I take out that 2, right, I'm left with n squared minus 9n plus 20, right? This is where the 2's on the outside. You don't worry about it anymore.
So you don't have to.
You leave it there, but you're not dividing out because what is my A term? It's 1, right?
No.
So 1 times 20. What are the factors of 20 that are going to multiply to give me 20, but add to give me negative 9?
Negative 5.
Yep, I still have my 2 out in front, but it's just n minus 5 and n minus 4. Do you see the difference there?
Yeah.
Yeah, okay.
And that's it.
And then we're going to end with this cupcake. GCF. Yes or no?
No.
No. My A term is 1. So 1 times 8. What are the factors of 8, guys, that multiply to give me an 8, positive? But when I add the two factors together, I get a negative 6.
Minus 4 minus 2.
Good job. K minus 4, K minus 2. Could I have written that K minus 2 times K minus 4? Yes. Now, at the end of the day, guys, 10 questions of factoring. 10 of these. 2 of these simplifying. So you have 1 simplifying and then 1 that's on the next page. That's the expanding the binomial, it's called. Where you have to write out we'll do that tomorrow. But you have to be able to ask yourself all of these questions. And when you turn in your test, you should know if the 10 factoring problems are correct or not, because you can FOIL them all back out and make sure that your answers are correct. If they're not, fix it. Find where you made your mistake. Don't just be like, oh, I can't do it. It doesn't work. Yes, it does. So let's look, all right? Test is Tuesday. You have one simplifying. Take your time. This -3 is distributed to the 3, to the 4, to the -3, and to the 1. Before you try and flip stuff and put it up and down and over and around, just take your time and say, okay, I have 3 to the -3rd. X to the power to a power, we multiply. Y to the 9th, Z to the -3rd. Now this is all over 1, correct? Anything that is a negative exponent, if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. So I'm going to move this down, and this down. Does everybody see that? Y to the 9th is going to stay on top.
Because it's positive.
Yes. So Y to the 9th on top, and then I have 3 to the 3rd, X to the 12th, Z to the 3rd. Everybody agree? And one more thing I can do is say 3 to the 3rd is what?
81.
Nope. Close.
27.
27. There you go. That's fine. All right. So again, you're going to have one simplifying, one expand the binomial, and I'm going to do 2 examples with that, and then 10 factoring, where it just says factor. So you got to factor, all right? Okay, so now we're going to do the same thing we've been doing 15,000 times. We're going to take this -2 and we're going to distribute it. There is a -1 in there in front. Don't forget. In this case, we need to remember to write the -1 because we have it raised to an even power. So I have -1 to the -2nd power. I have x to the -8, y to the -6, and z to the -18. Do you guys all agree with what I just did there? Okay, so now I'm going to take my -2 and I'm going to distribute to everything in the denominator. So I have -7 to the -2nd power. I have z to the -6th power, y to the 10th power, and x to the -22nd power. From this point, guys, some of you like to simplify in different ways, which is totally fine. If you want to start subtracting exponents here, fine. If you want to get them all lined up on top of each other, if you notice the x's are not on top of the x's and the y's and all that thing, if you want to make sure that all of your exponents are positive before you do any of that, whatever you want to do. I like to get everything to be positive first, so I can I like to work in positive numbers. So if it's a negative in the numerator, we move it where? The denominator. If it's a negative in the denominator, we move it where?
Numerator.
Perfect. So I'm going to rewrite this as -1 squared, and then up here, -7 squared. Agreed? Okay. Now my x to the -8, that's in the numerator, I'm going to write it on the bottom. And then my x to the -22nd, that's on the bottom, I'm going to write it on the top. Then I have my y's. Okay, I have a y to the -6 on the top. I'm going to write it on the bottom. I have a y to the 10th on the bottom. It's going to stay there because it's already positive. Yep, and then my z's, z to the -6 is going to go up to the numerator, and then z to the -18th is going to go down to the denominator. So now all of my exponents are positive. And now let's just simplify our numbers. -7 squared is 49, correct? -1 squared is 1, so we don't have to write it. So look at our x's. I have 22 x's on the top and 8 on the bottom. What's 22 minus 8? Positive 14, so it's going to stay up here in the numerator, positive 14. In the denominator, I have both of my y's in the denominator are positive exponents, right? So let's just add them together. So I have y to the 16th, good. And then I'm left with z's. I have 6 in the numerator and 18 in the denominator. What is 6 minus 18? 12. Where is my z to the 12th going to go? on the bottom in the denominator, because 6 minus 18 gives me a negative 12. If you guys notice, look at where the z's are. 6 in the numerator, 18 in the denominator. Wherever the exponent is bigger, that's where your variable will reside. Yes, ma'am. Okay, so there is our simplified answer. So you're going to have one of those, guys. Promise you. You will have one of these, guys, that says multiply. This does not mean take 3 and just go here and here. If it was negative x and negative 7 being multiplied, then, excuse me, that came out funny. Yes, you could. But that's not what this says here. This says take this value, negative x minus 7, and write it out 3 times. And then we're going to multiply. All right, we're going to leave this first one out here by itself, and now we're going to FOIL. You guys all can do this, no problem. Negative x times negative x is? X squared. Negative x times negative 7? Plus 7x. Negative 7 times negative x? Plus 7x. Negative 7 times negative 7? Plus 49. Combine like terms in the middle, and we have x squared plus 14x plus 49. And then I have my negative x minus 7 that I now have to multiply back in. All right, now I'm going to FOIL, or distribute, however you guys want to say it. We're going to multiply a binomial times a trinomial. So we're going to take our time. Negative x times x squared is negative x what? Cubed to the third. Negative x times 14x, negative 14x squared. Negative x times positive 49. So minus 147x and then minus 343. So you should have an answer, guys, when you expand this out that has 4 terms. You should not just come out with a binomial that has 2 terms because you just distributed the exponent. All right, let's do another one over here. Same thing. This says 2x minus 3 quantity cubed. So I'm going to write out 2x minus 3, 2x minus 3, and 2x minus 3. Does everybody understand why I wrote that parenthesis out 3 times?
Yes.
Okay. So now I'm just going to rewrite this first one here. And then I'm going to FOIL these two. So 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. Combine here in the middle. So you have 4x squared minus 12x plus 9. And then I still have my 2x minus 3 out in front here. And we just multiply again. Take your time, guys. 2x times 4x squared is 8x to the third. Agreed? Okay. 2x times negative 12 is negative 24x squared. 2x plus 9, 18x. Now I'm going to say my second term. Negative 3 times 4 is negative 12x squared. Negative 3 and negative 12 is plus 36x. And negative 3 times 9 is minus 27. So this big, long, yucky answer, we're going to simplify it. We're going to make it a little prettier. So I have 8x cubed. Negative 24 and a negative 12 gives me what?
36x.
Good. Negative 36x squared. Positive 18 and a positive 36.
54.
Good. Plus 54x, and then I have minus 27. And there you have it. So on your test, Tuesday, 10 factoring. Take out the GCF. If it's 3 terms, factor the trinomial. If it's 4 terms, group. If it's 2 terms, look for difference of perfect squares. But always, 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 always take the GCF out first. Then you're going to have one of those simplifying, where you just have a big old quantity with negative exponents. You're going to distribute the negative and move stuff around like you need to. And then you're going to have one of these expanding. Sound good? Okay, we're done. Now, all right, so when we come to a question like this is called expanding a binomial. I'm going to show you a trick Pascal's triangle. That will help us do this later on when it's raised to bigger powers other than 3. But right now, what we're doing is expanding. You're going to write negative x minus 7 how many times? 3 times. You have to write them out 3 times. You cannot just distribute here. And the reason why is you're not multiplying negative x and negative 7 together. You're subtracting. So our exponent rules of just distributing that power don't work because we're not multiplying them together. So just rewrite 1 negative x minus 7 out in front and then FOIL the second 2. So negative x times negative x is positive x squared. Negative x times negative 7 is plus 7x. Negative 7 times negative x is plus 7x. And negative 7 times negative 7 is plus 49. And what can I do with the middle here? Combine like terms. So x squared plus 14x plus 49. Everybody with me? And then I have my negative x minus 7. And then we just multiply again. All right, I'm not going to give you ginormous numbers. So these are a little bigger, but that's okay. So negative x times x squared is negative x cubed. Negative x times 14 is minus 14x. Negative x times 49 is minus 49x. Negative 7 times x squared is minus 7x squared. Negative 7 times 14 is minus 98x. And negative 7 and negative 49 is minus 343. Again, I don't expect you to do that in your head or anything. And now we just combine like terms. I have 1 x cubed, right? Negative 1x cubed. Then I have a negative 14x squared and a negative 7x squared. What does that give me? Negative 21x squared. Okay, negative 49 and a negative 98. What does that give me? So minus 147x and then minus 343. And that is your multiplying. You will have one of these. Every single version has one of these. No, because you're not factoring. Good question. You don't have to factor out that negative because we're not factoring. If you were asked to factor, then yes, you would. Here, guys, same thing. I'm just going to write out 2x minus 3 times 2x minus 3 times 2x minus 3. So FOIL. It doesn't matter if you FOIL the first 2 or the second. It doesn't matter. I just always leave that first one hanging out by itself. 2x times 2x is 4x squared. 2x times negative 3 is minus 6x. Negative 3 times 2 is minus 6x. Negative 3 and negative 3 is plus 9. Combine in the middle, and we have 4x squared minus 12x plus 9. And then I have my 2x minus 3, my 2x minus 3 still hanging out in front. All right, so now we're going to multiply again. So 2x times 4x squared is 8x cubed. 2x times negative 12x is minus 24x squared. 2x times 9 is plus 18x. Negative 3 times 4x squared is minus 12x squared. Negative 3 times negative 12 is plus 36x. And negative 3 times 9 is minus 27. And then we just combine like terms. So 8x cubed. Negative 24 and a negative 12 gives me negative 36x squared, right? 18 and 36 is plus 54x. And then I have minus 27. So there is my answer. All right, guys, so you have 12 questions on your test. 1, simplifying exponents. 1, multiplying when you have a binomial raised to the third power, and then 10 factoring, where you got to go through the questions. GCF, trinomial, A times C. 4 terms, grouping. If I have 2 terms, then I take the GCF out, and it's a special product. Then it's, difference of perfect squares, something like that. So just make sure you guys are practicing. Watch the video, and you guys will be good to go.